Okay, let's get started. Can everybody hear me all right?
Yep.
Great. So welcome back. Today we'll be talking about loading data and then finally working with Pandas data frames. First, we'll do like a recap of Pandas series since we also didn't completely get through this last time. This is going to be important. So Pandas series, as we kind of like talked about, Pandas is this library that allows us to manage like either arrays or lists or larger tables, and we'll be using them for data wrangling, for plotting, and all of these kinds of things. And Pandas does have, like, most importantly, the series and the data frame. And we started looking at the series last time. That's kind of like the one-dimensional version of it. And then we'll be talking about the data frame later today. So first, we import pandas as PD. And just recall that series have an index and the associated data. The index can be kind of like, it can be kind of like automatically generated. For example, it can start like at 0 and go to 4, or you can specify your index like in a dictionary with like a keyword. Here in this case, we have like names of various bands like the Stones, Beatles, Led Zeppelin, and Pink Floyd, and so on. We can create series, for example, using like this syntax. So here is kind of, this is the payload of our data. This is just the name that we give to the whole series. And then here we have our index. And so that index, kind of like the order here, matches to those years. And if we do that, we have our series here with like the names of the bands and the year they were founded. Notably, we have one of these indices or one of these bands in here twice. That is legal in series, which isn't something that is legal in, for example, a dictionary in Python. If we, that kind of like makes things a little bit tricky, because if we access an element of a series, we get different results depending on, are we accessing a unique element or are we accessing an element with multiple entries. And so if we have bands founded and ask for Pink Floyd, we get back another series. But if we put in Stones here, we only get back a single value. So this is like slightly tricky, but if you know what you're expecting, it's actually fairly convenient. Indexing and slicing works largely like in normal Python, but we can use direct bracket notation, but it's typically like we instead should use two different types of indexers. The ilog, which really goes by positional indexing. This is very much like a Python array. And the log, which is indexing by labeled indices. And so if we do this, we get exactly what we would expect in Python, for example, with a regular array. If we have bands founded.ilog, then we get like the element at index 1, the element at index 2, but not the element at index 3. So we get just like those two, Beatles and Zeppelin here. If we slice by labeled index, the last value specified is included, which differs from like your typical Python slicing behavior. So if we do Zeppelin to Pink Floyd, we get a result like this that includes both Pink Floyd's values. Both ilog and log can be used with arrays, which isn't possible in vanilla Python. So you can do something like ilog values at position 0 and 3. And you can also say log and then specific index names. So this is something that is very convenient. And of course, all of these variants can also be used with Boolean arrays, as we talked about last time. So here's our original bands founded. And then if we like applied this to it, with like this Boolean array with true, false, false, true, false, then we get only the rows where we have a corresponding true value. So in this case, like the first row and the fourth row are like in the result of this expression. This is kind of course, like not all that useful, but if you specify it manually, but this gets really, really useful if we combine it with masking. So here is kind of like this broadcast operation. We can take a series and do some kind of expression. For example, we can do bands founded greater than 1964, and then we get back such a Boolean array. So the Stones and the Beatles were founded before 1964, so those are false, false. And if we then apply this, which we do down here, we have kind of like the result that we want to achieve. Note that this kind of broadcasting, you can do this for like many different kinds of operations. So I can do this for like a comparison, but I can also do some math on a series like this. So for this particular case, this isn't all that useful, but generally that could be useful. And of course, this here is kind of like I'm creating the mask, storing it in a variable, then applying it. This is of course can do this on inline. So I can just say bands founded of bands founded greater than 1967. We can explore series. We can do things like getting count how large a series is. We can just print the series. We can get something like the sum, the mean, or the median of a series. And we can also get this kind of like overview of statistical properties. So whenever I look at a new data set, I look first at the raw data and I look at something like this where I just hit describe, and then I get a good sense of what the data is. This describe and all of these different operations, they simply ignore none or not a number value. So they're not considered in these calculations. If we want to just explicitly remove them, we can do that with like a drop NA function. And I'll talk a little bit more about handling not a number values later when we talk about data frames, not just series. This also works for non-numerical data, but we like, of course, categorical data would be slightly different. We get kind of different measures. So this is actually numerical data. So I forgot to copy that over from the old script. Anyways, we can also explicitly ask for quantiles or max or min. Okay, so this is what we covered last time, and now we're kind of getting into new territory here with sorting. So sorting is, of course, always useful, especially if you want to explore data. If I simply call sort values, it will do like an ascending sort. In this case, like starting at 1960 up to 2016. We can make the sort descending by putting in this parameter here. So if we have sort values and set ascending to false, we get this result here. And note that like here, the indices, as you can see here, they're not actual like indices by position, but these indices, once you have loaded the data frame, they kind of like remain associated with that row. And even like after you've sorted it, they like that just sticks to them. And sometimes that's what you want, especially if you have indices that are meaningful. But if you have like auto-generated indices, you might want to reset an index after you've done a sorting, so that this is really like the index 0 again. And we can do that with the function .reset index. And then with this parameter here, like if we do that, you can see this is like now looks nice as we expected it before. If we like the drop true here specifies that we don't care about an old index, because you can reset an index and pandas will actually keep the old index around. So if we do this, we suddenly start getting in a data frame. So that's why we need the drop in here, so that like telling it we don't care about the, so here we go. So we don't care about the like the old index, we can just remove it. And we can also sort by an index. So here I'm just like mixing this up first. And so this is my initial result. I have like mixed up indices. And then I can say like sort index, and then it gets sorted by the index. Again, useful in some situations. Okay, so sorting is fairly straightforward. The thing that's maybe a little bit more complicated and takes a little bit, I see Henry is asking a question, how important is the name we give to the series? It's really not important. It is really just something that you can use as an analyst to keep track of what is going on. So the name is more of like your personal convenience. If you don't need to give a name. Okay, so when we apply a function, that's where things get a little bit more tricky. So we've seen this kind of thing before when we did list comprehension. That's kind of the same idea, and we can do something like list comprehension with a map function. And so here, what I'm doing is I'm taking these sorted numbers of the years and I'm converting them to like a date. Like dates have like a year, month, and day of the month. Whereas here I just have like a number, right? It's like this, like pandas or it doesn't know anything that this is semantically a date or a year. So what I want to do here is I want to just take those numbers and convert them to a date. And so I wrote this little toDate function, and I pass in a year parameter, and then I return datetime.date, and then I'm simply saying my date is the year of, and I'm assuming it's January the 1st, which is just like for demonstration purposes, okay, of course. And if I then run the map function, I can put that function that I've defined here in as a parameter. So I can pass a function as a parameter to the map function. And then what I get now is I get these years, but now they are actually interpreted as an actual date in this case here. So we see this is 1960, 01, 01. So this kind of like doesn't make a ton of sense for this example here, but it is a super powerful concept that we can use to modify series in sophisticated ways, very similar to what we've seen with list comprehension. The other way that we can use this is we can pass in a dictionary that we then kind of like apply to matching objects. So for example, if we have like a long list of data that we loaded and we see here's like some values that are wrong and I want to manually correct them, I can do something like this. I can say .map and then pass in a dictionary. 1965 should actually be 9045, 2012 should actually be 99, and then 9068 should be like our string what. And we can do that, and we see that this actually works just fine. Okay, any questions about this mapping?
When you were doing the datetime.date before you have int and year, what is that a method in a Python?
Yeah, this is just one of those packages that you can import,
Okay.
where you can do some kind of like manipulation of numbers to dates and so on.
Wonderful.
So I could have done something simple here, like multiplied it by a value or something like that.
Okay.
Okay.
In your map, so anything that's not in the map max to not a number?
Yes, which isn't all that convenient in this case. So you probably want to look into like, how do I preserve that? And I actually don't know this from the top of my head. I would have to look it up too. Okay, I'll take a look at it, because this is actually not all that useful. And I'll post like a better solution to this later on Slack. Great. So now this kind of completes this series. We'll go back into data frames a little bit later, but I think I wanted to do a little bit about like loading data first and talking about different data types that we'll be encountering first, and looking at different methods and pros and cons of different methods of loading data. And so like up to now, we have been kind of like in the land of like super artificial, simple examples, right? Where I did specify all of my data sets, like the music bands or whatever, manually in code. This isn't how things work in reality, right? In reality, your data is stored somewhere in a file or in a database or in an API or something like that. And so now we'll look at what are the different file formats that we can encounter where this data is stored, and how can we load them. And there's a couple of different ways. So first, data, like often comes in structured file formats. The ones that we care about are comma-separated files, JSON files, or XML files. We do also care about databases, but I'll keep this like separate for now, and we'll just talk. Databases are not files, right? So we'll just talk about file formats. And we'll encounter all of these different file formats in class. JSON is kind of like probably the most popular file format for, let's say, more complicated text recently, for more complicated data. JSON stands for JavaScript Object Notation. And as you can tell by the name, object notation is that it can actually capture complex objects. So here I have, for example, a JSON where I kind of like have information about like a batch or about like apple shipments. The fruit is an apple. It's their large apples, their red apples. I have a nested array here that is like has 3 different batches. And then I have like a nested object in here where we have like the name of the orchard and when the orchard was founded. So this is really just to say that I can do complex data structures with JSON. It's easy to read. This works beyond tables. Similarly, XML, I can use complex data structures. I can do nesting. I can do basically everything that I can do with JSON. I can also do with XML, though kind of like XML has been super popular like in the 2000s, and JSON has largely superseded it. So for example, if you work with like a web API in 2005, they would have responded with XML. In 2020, you're most likely to get JSON back. So JSON is actually the more important format nowadays. These are complicated formats. We'll talk about them a little bit later. But today I want to hone in on the simplest form of like storing data, which is in comma-separated value files, CSV files. And CSVs are just text files. So you can open it up with your favorite text editor. And it's actually not a formally defined file format. It is rather a convention of like how data is stored in text. And that also means that it can vary a lot. How do 2 different CSV look? So you have to know a little bit about your CSV to actually do something useful with it. And so in these CSV files, you typically have cells that are separated by a delimiter. And so common delimiters are like something like a comma or a semicolon or a tab character. And by convention, but also not necessarily true in general, is that the first row is kind of like header information. So, many CSV files also have special conventions for dealing text that could include the delimiter. So let's take a look at this example here. I have a CSV file that has artists and then albums and then a genre of that album. And so I have like here an example of Michael Jackson's Bad album, which is kind of classified as a genre pop or funk or rock. But if I had looked at just the delimiter of a comma here, I would kind of like not get something very useful here, because those funk and rock wouldn't really map to a particular column. So what really is happening here is that I want to treat pop, funk, and rock as like one genre description, right? And so to do that, I have to kind of like make this explicit and use some kind of like escape character or some kind of like character to signify that within a certain kind of like character set, you shouldn't treat the commas as delimiters, but they are part of the text. And so typically this is done with these quotation marks. And so here I say Michael Jackson Bad, and then I have a quotation mark, pop, funk, rock. And now this basically tells a good CSV parser, this is actually like part of the string here. I don't want you to separate this into separate columns. Of course, if I now have double quotes in here, it gets tricky. And so if I wanted to deal with that, I would have to kind of escape special characters like double quotes in here with like an escape character. Again, there is no predefined way to do this, but it's fairly common to, for example, use a backslash to escape something. But if you use a notation like this, it is very clear that those are supposed to be in a single cell. And so for the rest of this lecture, like now for reading the data, but also later for processing like the data with pandas, I have gone to Wikipedia and copied this data set here of the best-selling albums of all time. And you can see there's like Michael Jackson Thriller at #1. And this is like fairly annoying, as you will see frequently on online data sources. This isn't made for automatic processing, right? It's actually in split in multiple tables. It's slightly inconsistent and so on. So I had to do some work to clean up this data, but I did that work, and we're going to talk about how to do this kind of stuff in the future. But for now, I've just like provided this file here in hitalbums.csv. You can see it in here, and you can open it up if you want to. And this is what this looks like. So we have like our header column here. And then we have like row after row with the various albums that are in this data set. Okay, so there are many different ways of reading a CSV file. We'll first cover the basic read and write operations for Python. This is more like educational, because sometimes you have to do that if you have some weird thing. But mostly we will use like either the CSV library that helps us do that, or we'll just use pandas. But it's still useful to know how to read and then write a file in Python directly. Okay, let's get started. So here I am like, now this is a way how I would open a file in Python. I can say open, and then I provide a path to that file. That path here is relative, so that means that my script is running in the same directory as this data is, but this could also be a URL, or this could be like a path somewhere else in your file system. And then I'm saying I want to read it. So R stands for reading. And so we have the choice of whether we want to read, write, both, which is R+, or append to a file. So if we do that now, like we don't see any output, we can try to read the whole file at once. And if we do that, this is what it looks like. So this isn't all that human readable. What is going on here is that new lines are delimited or are specified with like this special character \n. So that stands for a new line or line feed. Depending on your operating system, there might be slight variations in this here. In this case, it's just like a new line. And so this is what this looks like. And if we were to, like, I'm here, like I'm creating the output, I'm not printing this. If I were to print this, it actually would like look a little bit nicer, because print actually converts the \n character to a new line. So this is fairly like readable. This looks like the file. What I don't have here is any structure, right? This is just like row for row. I don't have this in any arrays or anything like that. And so if we want to kind of like make sense of this and do some data analysis on this data, we would have to take steps to parse this and to read this into some structured format. And this is what we'll be doing next. One thing that you have to be careful about, especially like if you write a real program that is being used over and over again, is that you don't leave any of these files. They are kind of like, they take resources from the operating system, and you need to close them. If you don't close them, you're potentially generating memory leaks, which is kind of like something that can be ugly in production file systems, in production software. So you just want to make sure that you close them. So alternatively, like I can read the whole file at once. If I were to write like a CSV parser, what I probably would want to do is read the file line by line. And so here I'm doing what I did before. I'm just opening this again. How is it different from with open? I'll talk about with in a second. With open is the right way to do it. With manages the whole context for you. So you don't explicitly have to close it afterwards. So yeah, if you already know what with does, with is the way to go. Okay, so now the difference here is this line here. I'm actually reading line by line. And so I can do this in this case for the first line, which is my, like I've stored this in line 1 variable, and I'm printing it out here, which is kind of the heading line. And now if we wanted to separate this out, we can split based on a comma to create like a simple CSV parser. And now, like if we run line.split, which is like a function that is defined on a string, we now have like an array that contains the headings of that file. So that's already fairly useful. Of course, it's slightly naive, right? It's not the perfect solution. And for readline, like every time I call readline, I get a new line, and then my next readline points to the next line. So I can just keep calling readline and then simply like get a new line every time I call it and work through the file like this. So this is what we can kind of like treat this albums file like a list, and that's kind of like, instead of running readline, I can just iterate over an albums file in like an iterable data structure. So I can say for line in albums file, and then I have like a data array that I create here, and then I'm appending a new a new array for every line where I split the line based on a comma. And what I get from this is like a nested array where I have kind of like something that looks like a structured table, but of course I haven't properly taken care of this kind of like escape character. So pop, rock, and rhythm and blues here are actually like treated as separate columns. So I would have to write a smarter parser if I wanted to take care of that. We can now, from this, we can now, of course, read individual cells or rows as usual. But yeah, as I said before, I didn't properly take care of this, but writing is something like a parser that takes care of double quotes, escape characters, and so on isn't particularly necessary. So what we'll do instead, we'll just use an existing library that does that for us. Another thing that you often want to do is write files. That can be useful, especially if you want to like store intermediary results beyond, like everything we've done so far is stored in computer memory, right? Nothing is written to the hard drive. But if you, for example, do like build a model or do some kind of like analysis that is computationally expensive, you can't just run it again without like incurring the cost of waiting or your computer taking a long time. And so you could store an intermediate result in a file and then open it up again afterwards. And so that's something that you'll be doing in homeworks and probably also in projects. And so to write a file, we can just open it with the W flag. And here's also this with keyword that that Louis mentioned earlier. This is kind of like an alternative way of opening a file, which is kind of like more elegant. I'm basically saying with open as new file. Then I can do something, and notice that this looks like an if statement or like a function definition, right? I have a keyword, I have something, then I have my colon, and then I have an indented plug. And so essentially, as long as I'm in indented space here, I can work with the new file, and as soon as I'm going back out of the indentation, the file is being closed. So this takes care of the opening and the closing for you, and it's kind of like the elegant way to do this. And so here, for example, if this file didn't exist, like in my computer it exists, but if it didn't exist, it would just be created. And then I can write something to it. And so if I execute this, you can see that I do have this file here, myfile.txt, which contains those 2 lines that I just wrote to it from my Python program. There's like more info on using basic file operations in the Python documentation that I'm linking to here. So now let's look at the CSV library. The CSV library helps us reading CSV data. It takes a delimiter and a quote char, and the quote char being kind of like in our case, what we've shown so far is the quotation mark as parameters. And so here's kind of like the most important piece here. We say, well, we import CSV, we initialize the top level empty array, we use the with syntax to open a file as CSV file, Then here's the file reader. We can say csv.reader, csv file. And then this is kind of like the interesting part here. We specify what is the delimiter in our file. Is it like a, in this case, just like a comma, and then our quote char is our quotation mark. And notice that, by the way, we in general in Python, you can use either single quotes or double quotes. They're more or less interchangeably. If you open up with a single quote, you have to close with a single quote, and vice versa. It's useful, like if you need either a single quote or a double quote in your string, just use the other one, right? Then you don't have to worry about escaping. And so I tend to use double quote, but I also tend to mix it. And so, but here it's useful. I assume so. Mike is asking default for with open is read. I'm assuming it might also just open it up as read right here. So yeah, basically by using a single quote, I can just specify the double quote here directly without having to do anything like escaping it or the like. And then I can go through this CSV. I can do for row and file reader. I'm printing the row, and then I'm appending my data values, like appending the row to my data values array. First, I also like, well, afterwards I remove the first row because that's a header. So I kind of don't want to, I want to treat my header separately from the rest of the table. And if I do that, this is my output. I get like, this is what's printed in all of the rows. You can see that we're parsing that file. Then here I have my header array. And then here I have my actual data array. And you can see that in this example here, it has taken care properly of like pop rock, of these nested, of these genres that are also separated by a comma. So this is something that I could use. One thing that is kind of like, we still haven't taken care of, like the numbers here are still treated as strings. So we would have to convert them. So we could do something like this here. So if we want to do any math on them, we could iterate over them and say we want to replace the row, the second element in the row, and cast it to an integer. We want to replace the fourth and the fifth one with floats. And so that seems like a good idea, but unfortunately in this case it doesn't work because the float function here, like there's some values. If we look at this table for like the claimed sales, we often have missing values. And so missing values are generally a problem that we'll encounter frequently. And so what we'll have to do if we wanted to cast it like this, float unfortunately doesn't assume that this is just like 0 or anything like that, or not a number. We would have to take care of this specifically. So this throws this value error. It could not convert string to float. And the way to handle this, and like now I'm introducing another concept through the backdoor more or less, is to treat this exception. So this is what actually this error is called, an exception. And exceptions are error state in a program, but they're not necessarily catastrophic error states, right? It doesn't mean your program can't crash. They can be just like part of your regular program flow. And you can like catch an exception and deal with that particular exception in any way you like. So what I'm doing here is like I'm take the same code here where I try to cast these two numbers, and then I say for a row in data values, try this. So this means that whenever an exception now occurs, like I kind of expect an error to happen here. And if that error happens, this is what you want to do. And specifically here, I'm saying, if I get a value error, this is what to do. And so now these empty values only exist in row 5. So I only have to take care of row 5. So try to convert it to float. But if it throws an error value error, I will convert it, like I will just assign none manually. And now this works. And now I have kind of like, you can see that these don't have any quotation marks anymore. So these are now actual numbers, which I can then use for some kinds of computations. So this is now like a data set that I could work with. One thing that's not great about this data set so far is that it is like last lecture I told you, you shouldn't have arrays with different data types, but here we are mixing like semantics and data types a lot. So we have like names, and then we have years, and then we have like the counts. So what you probably want to do is you want to like take this now and convert it into a data structure where you have the column-wise arrays. So you would have like one array for certified sales, one array for claimed sales, one array for the year that album was released, and so on. And so you kind of like want to transpose your like structure more or less. And then you can do like all kinds of math on it. But I'm not going to do that because with pandas, we also get this for free. And so I'll just show you the pandas way to do this. And so all of this code that we've done here, like this cell here and this whole cell here, where we have like—
a question, when you handled the exception, you only had one thing to do?
Yep.
But that exception could happen with any of those things under try, right?
It could, but I looked at my data, and I know that they don't have like empty values in these cells. So if I were to write like a general purpose program that for all cases wants to deal with that, I would do this thing here for all of these rows. But now that I'm scripting and only looking at a single data set, it's okay to just like do this because that's where the problem is. But if I were to expect other data sets and would write a library, I would do this here. So I would say these are also none. And this doesn't make a difference, right? I can take care of that separately.
So it only applies to where the exception happened.
Well, in this case, it's also if the exception happened here, this might not work as nicely either, right? So I would have to like, yeah, in practice, like this works for this particular case. If I wanted to make it generic, I would have to try each of them individually and accept each of them individually.
Okay.
Okay, so I can substitute all of this complicated code that we did up here with just a single line if I do pandas. And that's kind of cool, but of course it has its limitations. If you like don't have a CSV file, like this is not going to help you, right? If you have some weird file format, but if you have a CSV file, you can just do pd pandas.read CSV and then pass in your file path. And then what you get is this nice navigable pandas data frame. So this is very different. This is much, much easier, of course. And that's because like somebody has taken care of like implementing read CSV for us very painstakingly. And so you can see this is like a monster function, right? It takes so many different parameters. But like since what I kind of like read here that use commas and quotation mark, which is like fairly standard. So it guessed it correctly, or it was just by luck, it was the right default parameters. But you can specify like everything here. You can say the delimiter, the header, the like whatever. There's like many different the quote character, double quote, and so on. So all of this kind of stuff. With this library, you can basically parse most CSV files. If you have something more specific, you might look at these parameters, but you'll probably be happy with this particular function here. There are also other I/O operations in pandas. For example, I can read XML files, I can read JSON, I can read HTML tables, I can even read databases. So all of these things are possible with pandas. And so that's why we are kind of like using pandas so much going forward in this class, because it's just so convenient and it allows us to be efficient when we want to do data wrangling. Okay, it's 1:05 and it's a good time to take our break, our 5-minute break for today. We'll be back at 1:10. Okay, so now let's talk finally about data frames. We've loaded our first data frame here, and that's kind of like the data frame that we'll be using for most of the rest of the class. But since we have always specified data and code so far, we can also do that like this. We do pd.dataframe, and then here we specify just multiple columns. These are kind of like the headers of the columns, the name, number of members, and number of albums. And then here we have the payload, which is kind of stored in the column. And if we do that, this is what our data frame look like. And so here, this is our index. So 0 to 3 auto-generated. Name, number of members, and number of albums are our kind of like columns with the data. We can access columns in a data frame which returns just a series. And so this is where those two are connected, right? So each column in the data frame is a series, and I can retrieve it by just doing this bracket-based access for the columns. And so if you remember, I mentioned like column, like direct bracket-based access is for columns, and then the index or lock is for the lines. And so we can, this is kind of like roughly, and I'll talk about more detail about this later, but this is roughly the rule. If you want to access a column, use the square brackets directly, put in like your identifier. If you want to access a row, use the .lock indexer. I can also ask for, let's say, like you can see that this is a series here. And of course, the series, we can do everything that we learned about series to it. So all of this applies. It's also possible to create a data frame with like key value pairs. So like name, like row by row. Here we have like the row for Led Zeppelin. Here we have the row for the Beatles and so on. Here in this particular example, because I'm writing it out, this doesn't make a ton of sense. But maybe if you have your CSV parser, a read file by row, you kind of like have these things ready, right? So in that case, doing something like this might make sense. And remember that a series has only one axis. A data frame has two, one for the rows, the index or the 0 axis, and one for the columns, which is also called the column or the 1 axis. And it's kind of like important to understand them and to see what they are. And if we see like band info.axis, we get like the row index is our range index. So this is an automatically generated index, whereas our column index here is basically a list of column headers. We can also access these axes directly if we wanted to. So similar to what we did with series, we can also explore data frames. And very frequently, like now we'll be working with our hit albums data set. And if we are plotting, like if we work with larger data sets, what's nice about data frames is that we get like this interactive HTML table here. This is, by the way, something that only works in Jupyter notebooks, or like also probably in some other like IDEs. But if you just did a Python, like if you worked with Python on the console, that would look much different, right? So here, this is kind of like has nice syntax highlighting. But what it does here, it shows us the first 5 values, and then it shows ... and then the last 5 values. Often, if you want to look at the data set, you really want to look at the first and the last 5. So this makes sense. But sometimes you want to be more specific at what you want to look at. And sometimes you maybe only want to look at the heading, and sometimes you only want to look at the bottom of them. And so we can do that by specifying explicitly head or tail of the data set. So if I run hit albums.head, I get the first 5 elements. And I will do this like all the time. So most of the results I'll be plotting going forward will be looking like that. So we'll be changing a data set, we're manipulating it, and then we look at a couple of elements that are representative, and we can make sure that this operation worked as we wanted. But if you want to see more than 5 elements, you can specify how much you want to show. You can say, I want to see the first 8 elements. Or you can say, I want to see the tail. So in this case, we'll often also look at the tail, because the tail has these not and number values. And if you want to take care of these not and number values, we of course like don't want to look at the head where all of these are nicely specified, but we want to look at the tail. If we really want to see as many rows as possible always, we can also just tell pandas to always show me the maximum number of rows, which is a possibility. And if I do that, I actually get like the full like 70 rows here in my data frame. With 70 rows, it's fine. If you have 10,000 rows, right, this is going to be annoying. We can check out the shape of the dimensions of the data frame. So here we see we have 77 rows, we have 6 columns, or we can like learn more about the data set using the info method, which kind of gives us this nice summary. Most useful here is to see how many non-null values you have and what is the data type of the column. So once you load a data frame from a file, sometimes like if you're loading it, Pandas makes guesses about the data type, but very frequently you'll find that the guesses it makes about a data type are not correct, right? You sometimes like you want an integer instead of a float, and Pandas, just because the sum number was weird, is making it an integer. So you want to fix that. And this is like the quick way to look at what are the data types of each and what are the non-null values of each of the columns. Also useful memory usage, right? Everything that I'm doing here is in your computer's memory. Your computer probably has like pretty large memory nowadays, but it's not, this Pandas is generally not possible to use for data sets that are larger than fit in your memory. Like generally, I would even say that you need probably about 5 or 6 times as much memory as your data file is big. If you have bigger files, you have to use different approaches, for example, databases. As for the series, we can get like a rough description of what is going on. This gives us the description of the numerical values. So we have like counts, means, standard deviation, and quantiles. Here we can see the mean year is 1988. The mean certified sales is 22. Mean claimed sales is 35. Again, this is ignoring not in number values. If we have non-numerical types, we can kind of retrieve that series and then hit describe. And so we see that we have 56 unique artists in our table. The most frequent one is Michael Jackson, who has 5 albums in that list. So that already like it makes throws up an interesting question. Like, do we have other people? No, clearly we have other people who have multiple albums. And if we want to learn who those people are, we can just say .value counts. And now we see Michael Jackson has 5 albums. So Shania Twain has 3 albums, as does Madonna and the Beatles. And then we have like a lot of people that have only a single album in here. We can look at correlations, whether our numerical values in our data frame are correlated by just hitting by calling the correlation or the core method. And what we see here is, of course, we have perfect correlation between a column and itself, but we also have a very high correlation of 0.81 between claimed sales and certified sales, right? It's also not particularly surprising. You would expect that those correlate well. And if you want to, you can also transpose the data frame, which in this case is not all that useful. Okay, so slicing data is always important, and so we'll take a detailed look now at how you can slice data frames. As I said, we can access columns, but also slice columns using the brackets notation, and we can do the same thing for like rows with the lock indexer. So we can explicitly define the columns we want by their labels, but we can also pass in an array like we did for series. So like here in this case, I like want to get rid of these extra columns that I don't need, like the year, for example. I want to just look at the artists and when how much this artist sold. So I'm kind of slicing out this like D3 columns of that data set. And then I'm assigning it to this hit albums data frame here, and then I'm looking at the header of that. Slicing of columns, like if you like don't want to explicitly list them, you have to use the ilog operator. So something like artist to genre doesn't work. One kind of like weird break in convention that isn't all that elegant, but I looked actually up why they're doing this, and they say, well, it's just so common to slice rows this way that if you do numerical values like this, it will actually slice the rows. So this is kind of like, now goes against what I just said earlier, that direct bracket access is for columns. This here works for the rows, and the justification of the pandas theme is that people just want to do this all the time, and that's why they're providing this. So if you have like a numerical slice expression directly in the square brackets, it actually applies to the rows. Not very elegant, but here you are. We can also use this kind of like access methods to update the order. So for example, here I'm saying, like, I'm taking those column headers, but I'm putting them in a different order. And now I have kind of like reordered the columns in my data frame so that the certified sales are at the beginning and the artists are at the end. We can also set a column to be an index. That's kind of useful. Frequently, if you have like an explicit label column that, like, if you just read the file, it will not actually treat it as a label. There is like a way of specifying an index if you read the file, but it's also super easy to do it afterwards, to just set index. And now the artist here is actually the index, and it's not kind of like a series anymore, not a column, but it is the index of these rows. Okay, and now I want to get into the details of log, because this is such a powerful method. So far, I've always said log is for slicing the rows and square brackets is for columns, and this is generally correct. However, we can also retrieve both rows and columns using the log indexer. So, like, in general, this is the right way to do it. That is more performant. So if you read the documentation, accessing a column like we do here with square brackets is fine. But if you like do this later in a production system, you should use what I'm telling you next instead. And it sometimes is actually quite convenient. So the log indexer takes kind of like two parameters, or like parameters. Let's call it parameters. You have whatever you want to do to the rows, and then a comma, and whatever you want to do to the columns. And so with an expression like this, you can define any slice that you want. So for example, I could do something like this by like the hit album re-indexed .log meatloaf would just give me that particular row here. Or this returns like a series here. But if I have like an entry or like if I query for a row that has multiple entries with this key, I get back a data frame. So this is similar to what we said earlier in the series. It gives you back either a single number or a series, depending on whether you have like unique keys or not. So in this case, Michael Jackson is not a unique key, and so you get back another data frame. In this case, Meatloaf is unique, you get back another series. The second argument in log can be used to access the column. So for example, I can say log Michael Jackson, comma, certified sales in millions, and get the series of exactly his certified sales in millions. So now I've sliced this data set in two ways, right? I've sliced the rows and I've sliced the columns at the same time. Now here's an example of where I am doing, like, I'm asking for both Michael Jackson and Meatloaf, so like a subset of the rows and then a single column for them. And so I would get a series that has all of the Michael Jackson albums and then there's one Meatloaf album. And we can also use slice operations here. So we can say, what is the same data? What is the same data is in multiple columns? So if the same data is in multiple columns, I don't really understand the question. If I have redundant columns, I can just drop one, or if I have the same header of a column.
But there was an artist named Meatloaf and also an album named Meatloaf.
Yeah, but in this case, I have like up there where I chose what I want to use as my index. I actually said I want the artist, not the album name, right? I could have also chosen the album names as my index. That would have been equally possible. So here I can do things like I'm getting everything from Green Day to Supertramp, and I'm getting the certified sales from it. It's a different slice again, like here making use of this kind of like colon-based operation. We can also slice columns with logs. Like here, I'm just reloading the data set again so that I have more columns. And this here, now I can, with the log, I can actually do the slice operations, which I couldn't do with just our brackets. So I can do, there's two pieces of this here. This is the column-based slicing. So I want everything from artists to released. And the first part here, if I use log and I want to change the columns, but I don't want to change the rows, I just put in like the colon here, because this is basically like what we've seen in slicing operations before, that just says, give me a copy or don't change it. So give me everything. So like all of the rows, but only these columns is what this is saying. And so that's kind of like the best way of doing slicing, especially in production systems. So here would be a slice for the first 11 rows up to including index 10 and columns artists to released. This is just one example. So this takes index 0 to 10, including 10, because it's an index-based operation and not an like location-based operation. Similarly, if I use ilog, then this actually gives me only the, well, here I have to change it to 11 if I want to get the same result, because ilog does not include the last index. So that's kind of like the basics about slicing. So that's very powerful, very useful, and that you will frequently use these kinds of things. Okay, we talked about broadcasting for series. I can, of course, use broadcasting and filtering based on Boolean masks, just as we do for series. So here, like I'm showing you an example of like I'm converting certified sales to in millions to certified sales in actual numbers, not in millions. So I'm just multiplying this column here with a million, and then I'm creating a new column, certified sales without the millions, and adding that to our full hit album. And now you see I have certified sales millions and certified sales, both of them in this data set. Now we could filter out all the albums that were released before 1990. And so that gives us our mask again, where we have all the false and trues. And then we can, as we did for series, we can apply that. And we can see that since the 90s, Whitney Houston's The Bodyguard album was the most sold album. Of course, this is kind of the long version. Again, I can also do the short version. I can say full hit albums.log, and then use my broadcasting expression to get my Boolean array, and use this all in a single line, and then look at it. So this is equivalent. Okay, so we have a lot of not a number values in this data set. We have like basically claimed sales. We don't have them for the less popular albums. They are only there for the first 20 or 30 or so of the most popular albums. And like, what are like some ways that we could deal with this? First, we could, of course, drop everything. We could say drop NA. This is what we've done so far. The problem with this is, of course, now we're throwing away more than half of our data. So that's not all that elegant, right? So like we like suddenly have only 30 albums in our data set. What we can do instead is to fill our not a number values in some way. And what makes sense here is there is no general rule about it, right? You have to really think about how can you treat missing data? Like, do you want to interpolate it, or do you want to put in zeros, or like what are the different ways that make sense? The fill and a function here has a couple of things that you can do. So the easiest thing to do is set everything to 0. Like if I say hit albums.fill and a with 0, then you can see here my claim sales are 0. That's probably like not a good estimate for this particular data set. So what I might want to use instead is a forward fill method. So I could, by default, the forward fill method will use the value of the previous row to fill the value in the next row. So if I did that here, I would get like claimed sales of 30, because like the last claimed sales that I actually have data for is 30, and all the subsequent rows are then filled with 30. Maybe also not a great assumption here. So what's maybe better is to say, well, claimed sales, if I don't have any claimed sales, I'll just use the certified sales in that column. And so I can do that with fill and a, again, using the forward fill method here. I just have to specify that I want this on axis 1, which is the columns, instead of on axis 0, which would be the rows. And now what it does, if I look at this, like it's essentially whenever it doesn't have a claimed sales, like a certified, like whenever it doesn't have a claimed sales, it just copies over the certified sales. So here, for example, we start seeing this. Like here we have 29 million certified sales, and now it's just copying over this from the other column. That you could argue that this is a reasonable approach. You might also do something different, right? You might want to say, like, let's look at what is the difference between certified and claimed sales. Oh, we have roughly like an average factor of 1.2. Maybe we want to like not take this number and just copy it over, but maybe we want to multiply all of the values with 1.2 or something like that, right? It depends on like the data set, on your analysis, whatever makes sense to deal with not a number values here. Okay, so the last thing that I want to talk about is maybe also the most complicated. Now we are getting into grouping data frames because we want to aggregate data. And this is like also a very common operation. So for example, like in this data set, I have lots of artists that have multiple albums. Now, if I wanted to know how many albums did these artists sell, I could use a simple group by operation and then subsequent do something with these groups. And I realized that this takes a little bit of getting used to. So like I'm trying to explain it, but go through these examples and make sure that you understand what is going on, because that's kind of like an important piece, and we'll be coming back to these group by things when we talk about databases and so on. So we take the hit albums and say group by artists. And that just creates, now what we get here is like this new object that has these groups in them. And what this, like if I just print that, I can see that we have certain groups like Pink Floyd that have like an array of indices like 2 and 28. And so that tells us Pink Floyd, the group Pink Floyd has 2 members. Like most of them actually have just 1 member, because most of the artists here really only had 1 album in this list. But then people like the Eagles have 2, or Madonna had 3, or Mariah Carey also has multiple. And so that gives us kind of like a sense of what is going on here. So Michael Jackson's albums are found at indices 0, 10, 16, 65, and 66. And now once we have created these groups, we can specify what to do with it. And Pandas has a couple of built-in functions that make this easy. For example, we can just call sum. So here I take these groups and then I call sum on it. And what I get now is the sales here, like this, are summed up for these different artists. So I have ABBA, AC/DC, and so on, Bon Jovi. And now this is just like summed up. So that was kind of easy. we have not sorted them, so they're a little bit hard to see. If we sort them, we see that Michael Jackson actually sold in total 123 million albums certified, and he claimed to have sold 171 million albums. So yeah, that's kind of like what we wanted to do here. We use group by artist and then sum up all of their albums. An alternative would be like, if you want to see how many of them each of them had, we could also use the count method. So this is similar to what we had before. And I'm here just, well, I forgot this, the output. So if I run the count method, like group.count, and then sort it, I get this. So Michael Jackson had 5, various artists had 3, Madonna had 3, Shania Twain had 3, and so on. But this isn't, the column isn't correct. The column name isn't correct anymore. So we should probably rename the column here to show that this is a count, and this is what I'm doing here. I'm taking the certified sales and assigning them to a new column count. And now I have just a series. And we had another way of doing this before, right, with the value count method that we had directly on a series. So that would have been an alternative way. But this is kind of like the more general way that you can use on like a data frame with multiple columns at the same time. And then finally, the very generic solution is to use the aggregate function, which is very similar to what we saw earlier with the map function. Now we just simply pass in a function and tell the grouping by that function what we want to do with that. And so one very simple way would be to just pass in the sum function. That's kind of like the same result as we had before if we directly call sum, but here we have just passed in Python sum function, so we have the same data as we had before. But I can of course do something more complicated. So here I am summing it up, but I'm also converting it to converting it to like direct, like full numbers instead of millions, and I'm using what's called a lambda expression to do this. So I'll execute this row and you see what it does, and then we'll go through this. So here we can see now we have summed this up. We have, but we have also at the same time converted it to the to like direct, like to numbers, not millions. And so what I'm doing here is I'm actually just writing a function in a single line. That's what's called a lambda expression. So really, lambda expressions are just a different way of defining a function, a simple function in a single line. And they're also called anonymous functions because you don't have to give them a name. If you generally create a function, like if you have your def function name parameters, you have to give it a name. But for lambda expressions, you don't actually have to give it a name. So here would be like a simple lambda expression. I have lambda AB colon A plus B. So this creates a function that takes 2 parameters, A and B, adds those 2 parameters, and then returns the result of that. And in this case, I'm also assigning it back to a variable. So this is now actually very much the same thing as if I said def add AB, then return A plus B. This is more or less the same thing, but sometimes it can be convenient, like here, to just write, like not have to define a function somehow complicated before. If I just need it once and I don't want to reuse it, this is a way to do this with a lambda expression. And so then I can you can see that this works just as a function. I can simply call A with 2 parameters, add with 2 parameters, and that works. So what else is going on in this row here? I have this whole piece here, which is just a list comprehension, right? This multiplies every value by 1,000,000. So this is what we've seen before. And then we have, surrounding that, we have a sum. So all of these values that are in my array, just sum them up. And that's everything that's going on here. This is just like the function that I'm passing into my aggregate here. Of course, I could have also done this. Like this is a single line statement. if you kind of like are familiar with that syntax, this is actually fairly clear. I could have also done this. I could have defined a sum up and multiply by millions function, passed in the rows, then do my list comprehension here, then sum it up, then return it, and then pass in this function in here. But if I don't need this to like in another place, I could just as well write the lambda expression, right? So you can do it either way, but you need to understand what is going on here because you will see this kind of code occasionally. Okay. I want to conclude with just like very, very brief showing some built-in plotting because it's so easy. So I can simply say plot everything, and then it just takes it basically mostly it will show a line chart, and it will show you claimed sales versus certified sales, and you can see kind of like roughly what the values are for that. And you can see that certified sales and claimed sales often don't really align all that well. So that's kind of an interesting insight here. We can also see that certified sales have missing values, which like they're just not plotted anymore. We can like select a certain column and then just plot this. If we wanted to, like, we could sort this first, right? So if you wanted to sort that, we would just sort it first and then plot it. Or we can also say we want to see a bar chart. So if you say plot, you have this kind operator where you can say I like default is a line chart, but I really want a bar chart. You can say kind is bar. And then it does this in a bar chart for you, which doesn't make a ton of sense here because the line chart is actually more useful, but it's possible to do that. A better way to compare certified and claimed sales might be a scatter plot. So here I'm saying hit albums.plot.scatter, and then I'm saying what is my x-axis and what is my y-axis. And now I see that I can look at the correlation between the certified sales and the claimed sales, and we see that there's a kind of like some variation. Or I could do a histogram. And so histograms will just give me like the distribution of certified sales and claimed sales, in this case, on top of each other. This was just like the super easy things that are built into Pandas. We will look at more sophisticated plotting and data visualization in a future lecture. We have a couple of minutes left. I'll take like a question or two if there is any, and otherwise I'll start up the breakout rooms for our exercise today, where you'll do some data reading, some writing, and then a little bit of data wrangling with a data frame.
So this exercise is for discussion 5?
Yeah, as I said, like you can always submit them. You can submit them to activity 5, whichever you like.
Okay.
I was looking at it on the first example problem. Do you want us to use can we use pandas, or do we have to use like the Python read file?
The idea here is that you did it with like with open.
Okay.
If you use this in pandas, it's a one-liner.
Yeah, exactly. All right.
Okay, here are the groups.